Hey guys, today we're going to look at lesson 10.2 and we're going to start with task 1. So we're going to graph systems of linear inequalities. Remember, a system is two or more, and we've already graphed linear systems of equations, and now we're going to look at systems of inequalities. So we looked at inequalities in the last lesson, and now we're going to kind of tie two previous lessons together. So in the previous lesson, you learned to solve systems of linear equations. Now you will investigate a system of inequalities that consists of two or more inequalities having the same variables. A solution of a system of inequalities is any ordered pair that satisfies all the inequalities in the system. Okay, so that's important. Make sure you remember that when you're dealing with a system, okay, an ordered pair that satisfies all inequalities in the system. All right, so let's get started. It says the graph of the following system of linear inequalities is shown. So we have y greater than x plus 4. So we can see the dashed line here and shaded greater than. So this is the y-intercept of 4, and you can see a slope here of 1. So very quickly you know that that is the top equation or inequality. And it says 4x plus 3y less than or equal to 12. Again, you can find your intercepts very quickly by substituting 0 here and then substituting 0 here. And you can see 0, 4 and 3, 0 are your intercepts. This is a solid line because this is less than or equal to. It's also shaded below that line. All right, so the system of inequalities is everything above this dotted line and everything below and including this solid line. So your solutions will be everything in this area here. Okay? So remember that as we talk through these steps. All right, so it says you can verify the solution region by checking points from each region and on each ray algebraically. A point must satisfy both inequalities upon substitution to be a part of the solution for the system. Complete the table by entering a capital T for true and a capital F for false. All right, so they're giving us points. Remember, it's an X and a Y, and all we have to do is substitute that in. So if we put 0, 0 plus 4 is 4. 6 is greater than 4, so this one is true. All right, so let's take 6 and plug in 6. 6 plus 4 is 10. Is 0 greater than 10? This one is false. All right, let's plug in 0. 0 plus 4 is 4. Is negative 6 greater than 4? This one is false as well. All right, negative 3. Negative 3 plus 4 is 1. Is 8 greater than 1? Yes, it is. So this one's true. 2, let's plug in 2. 2 plus 4 is 6. Is 6 greater than 6? No, it's equal to it, but it is not greater than. So we have to check false. If this were a greater than or equal to, it would be true, but it's not. All right, so 3 plus 4 is 7. Is 0 greater than 7? No, that one is not true. All right, let's go to the next inequality. So 0. So if I plug in 0 here and I plug in 6 here, 6 times 3 is 18. Is 18 less than or equal to 12? That one is false. All right, plug in 6. 6 times 4 is 24. Is 24 less than or equal to 12? No, that one is false. All right, plug in a 0 and a negative 6. Is negative 18 less than or equal to 12? That one is true. I know I'm doing mental math kind of quick here. If you want to pause the video and work these out yourself first, I completely understand. I'm just trying to show you how this works, not necessarily if you can plug these in as quick as I can. All right. And then again, you may be quicker than me. I don't know. All right, so we've got negative 12 plus 24. Negative 12 and 24 is 12. Is that less than or equal to 12? And that one is true. And then 2, that gives us 8. 8 plus 18 8 and 18 is 26. Is that less than or equal to 12? This one is false. And then 12 plus 0, is that less than or equal to 12? That one is true. All right, now it says which one has true for both of these. So the top one, it was true, true, so this one has to be true. This one's true, false, so this one would be false. If it has at least one false, then it's false. False, true. This one is false. False, true, false. True, true, so this one's true. False, false. And this one is false, true, so that means this has to be false. All right, let's see if I did that correctly. All right, so again, to meet the qualifications to be a point inside the system, or to be a solution to the system, it has to be a solution to both inequalities at the same time. All right, which of the shaded regions are part of the solution? Select all that apply. All right, so we already said this right here is the solution. So let's see what it says. All 3 shaded regions? Nope. Only the 2 lighter ones? Nope. Only the darkest shaded region. All right, so this one is, it kind of is like overlapped. So this one's darker because it's showing that it meets this, it's below this line and it's above this line. So we can kind of mark it with arrows here. So it's below this one and it's above this one. So that's the correct region for us. My arrows did not look good, I'm sorry. All right, it says which of the rays are part of the solution? Okay, that's talking about the lines, the dashed or the solid line. It says the dashed ray on the boundary of the unshaded region. So that's not true. The solid ray on the boundary of the unshaded region. The dashed ray on the boundary of the darkest region. Or the solid ray on the boundary of the darkest region. All right, so which one's part of the solution? So it has to be a solid line, and it's got to be in the darkest region, which is all the solution points. We know if it's a dashed line, that does not include those points. All right, is the ordered pair 0, 4 part of the solution? All right, let's look at our graph. All right, if we go here, 0, 4. Okay, so it's on the intersection of those 2 lines. So it is a solution to this solid line, but it would not be a solution to this line. So that means it's not a solution to the system, even though it works for one of the inequalities. So let's see what our choices are. No, because it appears on the unshaded region. No, because it does not satisfy this inequality. That's true. That's the dashed line. That's the equation or the inequality that represents the dashed line. And these both say yes. So the only one it can do, the only one that will work will be the second one. All right, that's all for task 1. If you have any questions, please let me know. Lesson 10.2, this is task 2. All right, it says graph systems of linear inequalities. Previously, you learned that systems of linear equations whose graphs are parallel lines have no solution. Now you will learn that systems of linear inequalities whose graphs include parallel boundary lines will sometimes have a solution. All right, so let's look at an example. The graph of the following system of linear inequalities is shown. All right, so you've got y greater than 2x minus 5. So here we go, over here. It is a dashed line shaded below. All right, and this is y less than. This is y greater than 2x minus 5 and y less than 2x plus 2. So they have graphed this incorrectly. All right, guys, I paused the video since they have the wrong inequalities here because it says the graph of the following system of linear inequalities is shown, and this is not what this graph is. So the first inequality would be y less than 2x minus 5. If you see the y-intercept here and a slope of 2, less than means shaded below, and then y greater than 2x plus 2 is shaded above. So you can just kind of like change this in your notes. Don't have this because it is wrong. All right, so very quickly, if this is the inequalities, it would have been shaded above the one with the y-intercept of -5 and shaded below the one with the y-intercept of 2. So your shaded region would have been all of this here in the middle. Very bad drawing here. Let's see. Well, see if I can make it any better. All of this part here would be shaded instead of the way it is. So anyways, let's see what the questions say and see if they actually line up with the inequalities or the graph. All right, it says, which statements are true? Select all that apply. The region that represents this is shaded to the left. No, the one with the y-intercept here is not shaded to the left. The region that represents this is the unshaded region. No, the region that represents that is shaded to the right. Okay, so this is to the right, so that one is true, hopefully. Let's see, and the region that represents y greater than 2x plus 2 is shaded on the left. Okay, that is true as well. And unshaded region, shaded to the right, no. Okay, so if you look here, they actually have the correct inequalities here, just not up here. Let me check and make sure this is right though. Yeah, okay, so they just messed it up in the first part. All right, it says, does the system have a solution? Okay, so if we forget this system, if we go with this system right here, which is what the graph is, this system matches this graph, then this does not have a solution because there's no points that overlap that make both of these inequalities true at the same time. So in this case, there would be no solution. All right, it says you can verify the solution region by taking points from each region and substituting them into the inequalities. A point must satisfy both inequalities to be part of the solution of the system. All right, so if I plug in 0, 0 minus 5 is 0 less than -5. 0 is not less than -5, so that is false. All right, plug in 4. 8 minus 5 is 3. -8 minus 5 is 3. Is 0 less than 3? True. All right, for this one, is 0 greater than 2? 0 is not greater than 2. All right, and is 8 plus 2 is 10. Is 0 greater than 10? No. And then false, false is false. And true, false is going to be false. Remember, it has to work for all of them for it to be true. All right, if you switch one or both of the inequalities, you will get the system listed in the first column of the table below. Match each system to the description of its solution. Okay, so I have to visually look at these. So let's see, we've got a y-intercept of -5 and a slope of 2. We know that that's a line right in here, and we want greater than this line. All right, and then we have a y-intercept of 2 and a slope of 2, and we want less than that line. So that means the first one is going to be shaded between those regions. All right, the next two inequalities right here. So we're going to sketch that real quick. So I got a y-intercept of -5 and a slope of 2. And we want less than this line. And then we want a y-intercept of 2 and a slope of 2. And we want less than that line. So if it's less than both lines, then this bottom area here would be a solution to both inequalities. So it says the region shaded to the right. All right, so if we have the same thing except these are greater than, they would both be shaded on the other side, which would be to the left. All right, that's all for task 2.